Hello, everybody. I'm going to show you how to put all the numbers in and use the right functions using order of operations to evaluate the expression that's embedded in the great application problem involving the cyclical nature of temperatures throughout the year. This is problem number 9 from the sections 6.3, 6.4 post My Math Lab homework that's due tonight. You're getting a snapshot of the TI Smart UCE emulator that I have on my computer that I'll be using during screen captures and screen shares, that is, if we have to go into remote mode next week. I am starting to feel better today, so hopefully I test negative on Sunday and we're good to go. So first thing that we have to do is make sure our calculator is in radians mode. So if I click the mode button, you'll notice that I'm in degrees mode. So I have to go down to the radians and push enter to make sure that my calculator is in radians mode. For some of you, you'll have to change it from DEG to RAD to be in radians mode. So I'm going to go back to my home screen. I want to show you step by step how putting 125, the domain value of 125, correlating with the 125th day in the year, which is May 5th, into this model will come out with the temperature on that day. So first of all, the innermost parentheses should be done first, which implies 125 minus 91 is evaluated. That value of 34 needs to now be multiplied by the B value that accounts for the period being 365 days and assumes that the model is using radians. So I'm going to multiply that by the quantity of 2 pi. Notice the pi on my calculator is second exponent, divided by 365. And this is essentially the value in radians that's less than pi over 2 that I'm going to be putting into the sine function while it's still increasing through the first quarter of its period, not quite reaching its max value, which would occur on, I think, the beginning of July, at the beginning of summer. So when I take the sine of this value in radians, this is the percentage of the amplitude that I'm positively going to be adding to the moderate temperature of 37 degrees that just occurred. So when I multiply that by 21, that's the amplitude. I get the amount that I'm going to be adding to the moderate temperature of 37 to arrive at 48.6, which is the temperature, the average temperature in Fahrenheit for May 5th, the 125th degree day of the year. Notice that if I do all this from scratch and do everything in one fell swoop, it's 37 plus 21 times the sine of the quantity 2 pi divided by 365, all times 125 minus 91, the same value is yielded. If I am in degrees mode, which I should not be, you'll notice that by going back to the home screen and pushing second entry, I re-execute the command and get the incorrect value. So you've got to make sure that you're in radians mode. Throughout the rest of the class, you're going to have to always know when to be in degrees mode versus when to be in radians mode. Have a good day.